This short video highlights key components and capabilities of the Neuron platform and our unique approach to solving complex, multi-source, and distributed business problems. The Neuron platform is comprised of three web applications. First, the Design Studio, which manages all aspects of solution design, development, and deployment. Second, the Neuron Dashboard, or Enterprise Control Manager, which provides for visualization and manipulation of processing results by authorized end users. And third, the Neuron Administration Tool, which controls from a single point all platform deployment aspects and user administration. A fourth component is the Cortex, a lightweight runtime server which manages all distributed processing, resiliency, performance, and message delivery. Within the Design Studio, the canvas is a workspace where individual networks are built and configured. Each individual neuron is selected, configured, and connected to one or more subsequent neurons to form a distributed instruction chain which can be deployed across an environment either on a single server or geographically dispersed neuron servers. The individual neurons are organized into libraries, including a data interaction group to provide a rich set of mechanisms to extract value or data from underlying systems, the analytics library, which includes the entire Apache Math library, advanced matching algorithms, and even the ability to run predictive models. Third, an output library to deliver results of interest to a variety of destinations, including databases, web services, and email. As individual neurons are selected, they are individually configured according to the respective properties within that type of neuron. Here, a query neuron is being selected by choosing a data source and then configuring the specific query within that data source to target specific information that is required for that particular business problem. Here, a single table is being shown and the available fields within that table. By individually selecting a check mark, that field is added to the dynamic grid, and as individual aliases, sorts, grouping, and criteria are specified, a dynamically generated SQL statement is developed. Upon receipt of an incoming message, that individual neuron will execute that configured set of instructions, produce a result set, and then pass that in the form of a self-describing XML message to the one or more subsequent neurons in this distributed processing chain. A second example of a neuron is a matching neuron. Here, an arbitrarily complex set of routines can be established to build an analytical routine to handle complex matching tasks, leveraging the embedded library within the matching neuron itself. With this diagram editor, you have a rich ability to create a complex routine with declared local variables, operations to set the value of those variables, the use of if and while loops to provide recursive processing, and the ability to fire other parts of an existing network. Within this set step, we can even further edit the formula that is being leveraged to accomplish this matching task. Within the Runtime tab, we see the list of all available fields that are being passed in the XML message as an incoming source of information, and we can select from a rich set of libraries which particular processing algorithm we would like to apply in this example. As we look at the matching library, there are dozens of high-end matching algorithms that are already embedded into this neuron that can be applied with a simple click, and then using the field names as inputs, the proper processing can be specified. Once the processing network has been fully configured, the results are generated through the stream of execution. It is important to note that results are not persisted until a designer specifies where, when, and how specific results will be delivered and perhaps persisted outside of the neuron environment. Here, an update neuron is writing results into a relational database. As we visualize these results in the web dashboard, we can use a variety of graphical widgets to represent the results of processing, individual accumulation of results, and even the disposition of results through the processing network. One unique aspect of Neuron's dashboards is the tight connectivity between the dashboard and specific design parameters within the design itself. By exposing these design parameters, the network designer can allow end users the ability to reconfigure specific parameters or filter values that can be dynamically changed and have the results immediately reflect as the widget is refreshed. Widgets can also be set up in a parent-child relationship where the selection of an element within a parent can cause the refiltering of a child widget, which itself could be the parent to a successor child. Here we're looking at a specific customer and the details of his specific accounts across a global bank. Another example of a rich dashboard is the visualization of specific customer risk analyses. Here we wish to see a more graphical and more geographical representation of results, and so we have profiled specific high, medium, and low risk ratings, a distribution of risk scores, the geographic alignment of high-risk customers by country, a heat map of significant countries in terms of the distribution of high, medium, and low numbers of customers, and again, the full details on a customer-specific basis in the form of a child table. For example, selecting a specific country within the heat map, you can see a filtered list of customers that are specifically within that select group. Thank you for your attention.